In this video, we'll go over using reference angles to find answers, the set of all solutions to questions like this. So sometimes you have to find theta such that sine of theta is equal to 0.331. So we'll start with that kind of question, and then we'll look at a excuse me, a follow-up, something like find the theta such that sine of theta is equal to negative 0.331. And we'll kind of briefly touch on sort of the cosine versions of these kinds of questions. And you might have to deal with a different number, but a lot of the same ideas should certainly apply when you look at this. And then finally, maybe if there's a little bit of time at the end, we'll look at something like that as well. So let's just take this first one right there. Actually, before we take this, let me just make the following comment that sine inverse of any number k, doesn't matter what number k you pick, will either be undefined or will always be between negative pi over 2 and positive pi over 2. And just remember that positive pi over 2, that this is approximately 1.57, so then this number is always going to be, well, this is going to be approximately negative 1.57. Okay, so in radian mode, if your calculator is in radian mode, then you'll always get a number in between these two. For sine inverse, that'll be important a little bit later. Cosine inverse of any number k is either undefined or between 0 and pi. And tangent inverse, I mean, this is sort of maybe not every details here, but sine inverse can give you the number pi over 2, and tangent inverse does basically the same thing but can't give you the number pi over 2 or negative pi over 2. I like to draw in a unit circle. Oh, that's awful. Let's try that again. I'd like to try in a unit circle, finding the solutions to the equation here, to sine of theta is equal to 0.331. And let's just only look at theta in the interval from 0 to 2 pi. And you could, look at variants of this problem for different intervals other than 0 to 2 pi. But this is asking find the angle where the associated point on the unit circle has y coordinate, because sine, so y coordinate, has the y coordinate equal to 0.331. Well, here's where the y coordinate is 1, and here's where the y coordinate on the unit circle is 0. And somewhere over here in the middle, the y coordinate is a half. Or to be maybe a little clearer, it would be maybe a little easier to draw in the 0.5 that's there and say that if you follow this along, you get a point where the y coordinate is exactly 0.5. But what we have is, well, roughly a third. So let's chop this right here from here where y is 0 all the way up to here where y is 1 into 3 equal sized pieces. So maybe kind of roughly about there might be where you get 0.331. And so if you follow this along just horizontally, that point right there, that's a point on the unit circle where the y coordinate is 0.331. And of course the picture is not perfect, but this is not the only point. There's another point, at least when you look between 0 and 2 pi radians, where this will occur, and that occurs just directly on the other side. So if we draw in the terminal sides of the angles that we would like to find, our goal is basically to find this angle right here, and then to find this angle right there. Now, how are you going to do this? Well, you can take this equation and now rewrite by swapping the input and the output, and so you have sine inverse of 0.331 is equal to theta. Now this is one spot where it will be a little bit useful to use a calculator, and I know that in general this won't be a good thing to do in this class, but here, and you don't need to do this on a calculator, but it's good to just get a feel for what's actually going on, and so that we have a little bit more concrete stuff to work with. So I'm going to go to Google and type in arcsine of 0.331. Arcsine of 0.331, and what I get is 0.337 radians. So let's just kind of copy that down over here. Theta is approximately 0.337 in radians. Just as a reminder, this is pi over 2 radians right here, right at 90 degrees, and here theta is approximately 1.57. Okay, so our angle, this 0.337, is actually going to be probably this angle right there. But now what we have to do is describe the other angle, and here's where you should use reference angles. The point is, the angle that we want to find has this reference angle, and the other angle we want to find has that reference angle. Okay, likewise, we can now look at finding the thetas, which are in the interval 0 to 2 pi, such that sine of theta is now equal to negative 0.331. Well, there's approximately negative 0.331. So the corresponding points on the unit circle are here and here. Okay, so let's draw in the terminal sides. And now the point to keep in mind is that due to the fact that sine is periodic, there are many, many angles. When you take sine of that angle, you'll get negative 0.331. But we only want the ones that are between 0 and 2 pi. And there's only 2 of them. So we've drawn in the points, but let's really draw in this, curvy arc, the arrow, to really show which angles we really want. And so one of those angles really looks like that. Okay, and another angle looks like this. So now we can take this equation we were given, flip things around here, so switch the inputs and then the outputs. Sine inverse of negative 0.331 is equal to theta. So this looks pretty much like what we had before. If we go back to Google, all we have to do is just throw in a minus sign inside the input to arc sign like that. And we actually are going to get negative, the same number we saw earlier. So we'll just record this, negative 0.337. So theta is approximately negative 0.337. And so if you were to draw this angle, let's kind of highlight this angle. This negative sign right there actually means the angle that you have is this angle, right? The negative sign means this is a clockwise angle. And so really, I'm trying to draw the arrow to illustrate what's going on. We end up at the same point on the circle, but that's not the point we want. What you have to do is use the fact that the reference angle in the fourth quadrant will be this, although a reference angle has to be positive, but this angle is negative. So take the absolute value of this angle. So the theta r is approximately absolute value negative 0.337, and you really shouldn't use this approximate. I mean, you can just go back here, right, and use theta r is going to be absolute value of sine inverse of negative 0.331. And the point is that this number will be approximately positive 0.337. And if you want a WebWork sort of way to type this in, you could start with a negative 0.331, surround this in parentheses, change that sine inverse to an arc sign, and then for the absolute value again, throw in a set of parentheses and write abs for absolute value. That's one way to do it. You can also use this vertical line on the keyboard that you have. That's probably close to a backspace, but you'll have to hit shift to get that. Then once you have this reference angle highlighted here in magenta, this positive number, you can use the reference angle which appears there and there to get the two angles that you want, which are highlighted here. And whoops, and let me undo that. Highlighted, here's one of them. And actually, I think my earlier arrow was not so good, but we should start right on the positive positive x-axis and go up to here. Okay, same sort of deal for cosine of theta is equal to 0.331. Now we're looking on the x-axis, and we want I've sort of tried to split this into 3 equal sized pieces. So here's approximately 0.331. So here's one point on the unit circle where the x-coordinate is about 0.331. And the other point is not going to be over here. Here's where the x-coordinate's negative over on this half. But there's going to be another point down here. Now if you recall what happens with cosine inverse is always going to give you an angle that's between 0 radians and pi radians. So there's always these two solutions on the unit circle, but cosine inverse is going to actually end up giving us this solution right here. So though there's this is one of the angles we'd like to find, and the other angle we'd like to find, since we're looking between 0 and 2 pi, the second angle we're looking for is that one. Cosine inverse is actually going to give us a solution that we want, since we want everything between 0 and 2 pi. And cosine inverse will give us the solution that's between 0 and pi. So cosine inverse is actually going to give us this angle. But that's not the only solution we want. There's another solution here in the fourth quadrant, which you can find actually has the same reference angle. All right, is that really the angle that cosine inverse is going to give you, this angle that we highlighted in the first quadrant? Yeah, that's really the case, because cosine inverse of 0.331, this is a good calculator step, happens to be 1.23, and remember that 90 degrees, which was pi over 2 radians, is approximately 1.57. So you are indeed getting an angle that's in the first quadrant. Now, if we go back, we can look at the case of, now, how about the x-coordinate on the circle being negative 0.331. So that's going to be that point and that point, roughly speaking. And so if we draw in the terminal sides of the angles that we're going to want, these are the points on the unit circle, but so many angles correspond to them. And the angles between 0 and 2 pi again, that one and that one. Okay, so same thing here. You can swap these around and you can get that theta is equal to cosine inverse of negative 0.0331. Is this one of the solutions that we want? Well, yeah, because cosine inverse gives you cosine inverse of anything will give you something between 0 and pi radians. So if you're getting an answer between 0 and pi radians, it's really going to be this one. But we can actually check, right? So here, go back to Google, type this in, and you get 1.908 radians, so 1.91 approximately. Approximately 1.91 radians. But remember, this right here was 1.57, so we do get something that's kind of over here, but still smaller than pi. And now the point is we have a second quadrant angle, so we could draw in the reference angle like that. And the other angle we want to find is in the third quadrant, whose reference angle looks like that. And so you can use the reference angle to find the angles that you're looking. Okay, what about for tangent? We actually did one like this in class, and tangent ends up actually being much nicer than the case of sine and cosine, believe it or not. But I'm actually going to go not to the unit circle now, but actually the graph of the tangent function. Now, this picture is not maybe the best, but I'll try. And right here, this there's an origin crossing. This is actually going to be pi. If you think about tangent theta is sine of theta over cosine of theta, so this is the first time where sine of theta is going to be 0. That happens at pi. And then you have 2 pi there. There are these asymptotes that are probably worth drawing, at least for now, just for good habit. Okay, and that happens at pi over 2. There's another asymptote over here. Sorry if this picture isn't quite perfect, but this is 3 pi over 2. Oh, this number should be halfway between these two, so apologies for that. Now the point is, when you look at the output of your function, so 0.331 here, that's the point that you'd like to find, but that's not the only solution between 0 and 2 pi. If you travel along right here, there's another solution. Now, fortunately, these two solutions are a distance of exactly pi away, right? So this is a sort of a depiction of the period, this sort of double arrow that goes between the two vertical asymptotes. The length of that is pi, and that means that the length of this arrow here is actually also pi. So you can take this solution and add pi to that. What is tangent inverse going to give you? Right, so just same sort of deal as before. Do tangent inverse 0.331. That's equal to theta, and tangent inverse will always give you something between negative pi over 2 and pi over 2. So you're actually going to get this angle by doing this. And we can check. We can go to a calculator for this. Arctangent 0.331. This is a good spot to do that. And you get 0.319. All right, so that's right here. So the angle that you're getting is 0.319, and if you add pi to that, you'll get the next angle. And in fact, if we cared, we don't need anything beyond 2 pi, but if you wanted to, for tangent, you can just add another multiple of pi, and you'll get that angle right there. So this angle will actually end up being tangent inverse of 0.331 plus pi plus pi.